Y prime, y is equal to 2 over the square root of 3x squared minus 7. I can tell because we have a square root that we are going to get to use the chain rule, but before we do that, let's rewrite it. This is really 2 times the quantity 3x squared minus 7 to the negative 1/2 power. Okay, now I'm going to do a u substitution, so I'm going to let u be what's in the parentheses. So this is really 2u to the negative 1/2. So when I find the derivative, just using my simple power rule, 2 times negative 1/2 would just give me negative 1 u to the negative 3/2 because I'm subtracting 1 times the derivative of u. The derivative of 3x squared minus 7 is 6x. And now just cleaning this up a little bit, we'll have negative 6x will stay on the top. The u will become to the bottom and become a 3/2, and then just replacing my u, I'll have negative 6x over 3x squared minus 7 to the 3/2 power. Okay, number 12, differentiate again, find the derivative. F of x is equal to tangent of 7x. So I like to put parentheses around that. So since we have the tangent of a function, I'm going to let this be u. So we have tangent of u, and I'm going to go ahead and find the derivative. The derivative of tangent u is secant squared u times the derivative of u. The derivative of 7x is 7. And then from here, I'm just going to bump the 7 back out front. So I'll have 7 secant squared of the u is 7x. Okay, for part B, f of theta is equal to cosine squared theta. I'm going to rewrite this as the cosine of theta quantity squared, which means I can now do a u substitution. So this is really u squared. So when I'm finding the derivative of u squared is going to be 2u times the derivative of the cosine theta. The derivative of cosine theta is negative sine theta. Okay, I'm going to bump the negative out front with the 2, so my f prime will equal negative 2u, and the u was cosine theta again, and the derivative was sine of theta. So that will be my answer for that one. Okay, number 13, find the second derivative of y equals 2x over 1 plus x. Well, I do notice that this is a quotient, so let's use our quotient rule. F prime will equal 2, g prime will equal 1, so I'm ready to use the quotient rule. F prime times g, 2 times 1 plus x minus f times g prime, 2x times 1, all over g squared. Now cleaning this up, if I distribute, I will get 2 plus 2x minus 2x all over 1 plus x squared, and then simplifying, the x's cancel out. So I know my y prime is equal to 2 over 1 plus x squared. Now I have to take the derivative again, and you could use the quotient rule, but since 2 is just a constant, we can actually just move that up to the top. So another way to rewrite this would be 2 times the quantity 1 plus x to the negative 2. And now I can use the chain rule. So this is going to be my u, so I have 2u to the negative 2. So my second derivative is going to bump my power out front. I'll get negative 4u to the negative 3 times the derivative of 1 plus x, which will just be 1. So now just rewriting this, my second derivative is going to equal negative 4 over 1 plus x to the third power. Number 14, find the derivative. F of x equals x to the 5th times e to the 3x minus 2. Notice again I said the word times, so we once again get to use the product rule. All right, so then when we do this, f and g, my f prime will equal 3. Does that say 5 or 3? I crossed it off now. 5. This is going to be 5x to the 4. My g prime, if I have an e, it's going to be e to the u times du. So e to the u will be e to the 3x minus 2 times the 3x minus 2, which will be 3. And I'm just going to rewrite that as 3e to the 3x minus 2. Okay, now taking the derivative, using my product rule, f prime times g, 5x to the 4th, e to the 3x minus 2, plus f times g prime, x to the 5th times 3e to the 3x minus 2. And I'm going to look at what they have in common, and that would be an x to the 4th, so I'm going to factor out an x to the 4th. So I get x to the 4th. Oh, and actually they both have an e to the 3x minus 2. Okay, so if I factor that out, I will be left with 5 in the first term, and I will be left with 3x in the second term. So that would be my derivative. Okay, number 15, find dy dx. If y to the 3rd minus 4 to the 3x plus 3x is equal to 2y to the 4th, notice that this is an implicit differentiation problem, so whenever I take the derivative of y, I do have to attach dy dx. So the derivative of y to the 3rd will be 3y squared dy dx. Okay, minus, Okay, this is an a to the u problem, and we know the derivative of a to the u is a to the u du ln a. So, and this is my u. So a to the u would be 4 to the 3x times du, the derivative of 3x would be 3, times the natural log of the base, which would be the natural log of 4. And then plus the derivative of 3x is 3, and then equals the derivative of 2y to the 4 will be 8y to the third dy dx. Okay, the next thing that I want to do is anything, I think I'll move this over with the other dy dx, so we're going to have negative 4 to the 3x times 3 ln 4 plus 3 is equal to 8y to the third dy dx minus 3y squared dy dx. I now on the right side can factor out a dy dx, so dy dx 8y to the third minus 3y squared. This will still be negative 4 to the 3x times 3 natural log 4 plus 3. And then the last thing we can do is just divide both sides by 8y cubed minus 3y squared. So my final answer is going to be dy dx equals negative 4 to the 3x times 3 natural log 4 plus 3 all over 8y cubed minus 3y squared. And if your answers happen to be exactly 100% opposite of mine, you have the right answer as well. Okay, number 16, find dy dx. We have x to the fourth times 3x plus 5 cubed. So I notice I said the word times again, so once again, product rule will be happening. And I do notice I have parentheses, so when I do g prime, we're going to have a quotient rule. Chain rule. Okay, f prime will be 4x to the third. For g prime, this would be like u to the third, so my derivative is going to be 3u squared times the derivative of 3x plus 5, which will be 3. So this will actually be 9 times the quantity, 3x plus 5 squared. And then from here, we are ready to do the product rule. So f prime times g, 4x cubed times 3x plus 5 to the third power, plus f times g prime, so x to the fourth times 9 times the quantity 3x plus 5 squared. And then from here I would like to see what I can factor out. I could factor out an x cubed and a 3x plus 5 squared. And when I do that, I will have 4 times 3x plus 5 left, plus 9x left, it looks like. Okay, from here I'm going to distribute that 4. So I'm going to get x cubed, 3x plus 5 squared times 12x plus 20 plus 9x. Now I'm going to combine like terms right here. So at x cubed, 3x plus 5 squared, and then 12x plus 9x will be 21x plus 20. And then I think we found the derivative. There we go.